وطلبات شهادة الثانوية العامة قسم رياضيات لغات. أهلا بكم. اليوم سنتناول مراجعة على تطبيقات على قوانين نيوتن. طبعا قوانين نيوتن في قانون أول والقانون الثاني والقانون الثالث. هنبدأ إن شاء الله هناخد الآن على تطبيقات على القانون الأول لنيوتن. Welcome my dear student in our math program for second 3. Today we are taking new lesson. It's titled Revision about Application of Newton's Law. Now we are starting problems about the first Newton law. My dear student, at the first, look at the first example. Look at in the opposite figure, my dear student, body moves horizontally, moves in the direction down with uniform velocity of magnitude 8 meters per second. Find F1 and F2. Look at, my dear student, the solution. Look at, my dear student. The body is uniform motion state. Uniform motion state. Uniform motion means the horizontal are in equilibrium. Uniform motion. Uniform motion means equilibrium in horizontal. Thus, we reduce that to F1 plus 90 equals 300 plus 120. Therefore, 2F1 plus 90 equals 300 plus 120. Therefore, find the value of F1 equals 165 Newton. The vertical are also in equilibrium. Therefore, to find the value of F2, write equation 240 plus F2 equals what? 400. Therefore, F2 equals 160 Newton. My dear student, look at another example. A train of mass 200 ton moves under the action of resistance proportional of the square of its velocity. Train of mass 200 ton moves under action of resistance proportional of square of its velocity. If this resistance is 9.6 kilogram weight per ton of the mass of the train, when the velocity of the train is 72 kilometer per hour. Find maximum velocity for the train if the engine of the train can enter pole it with uniform force of magnitude 4.32 ton weight. Look at solution. We have resistance R1 9.6 each ton. Then resistance is mass 9.6 times 200 equals 1920. Then V1 equals 72 km per hour. Let resistance R1 when the velocity V1. R2 resistance when the velocity V2. The resistance is proportional to square of the velocity. What is the rule? Excellent student. R1 over R2 equals V1 square over V2 square. Therefore, the train reaches the maximum velocity when the resistance is completely equal to the force of pulling the train. If V2 is maximum velocity for the train, R2 equals 4.32 ton weight. Therefore, multiply by 1000 to convert to kilogram weight R2, resistance of R2, 4,320 kilogram weight. Since R1 over R2 equal V1 square equal over V2 square, resistance are proportional with square of the its velocity. By substitution, 1,920 over 4,320 equals 72 square over V2 square. By using cross multiplication, V2 equals 108 kilometer per hour. In this case, the relation R1 over R2 equals V1 square over V2 square. From the given, the resistance are proportional with velocity of the train. Another example. My dear student, parachute lands vertical as the parachute is open if the total weight of parachute and equivalent is 90 kilogram weight, and the resistance is proportional to the square of its velocity, and longing maximum velocity of parachutist is 15 kilometer per hour. What is the required? Find air resistance of parachute when his velocity is 10 kilometer per hour. Look at the solution. My dear student, look at the opposite figure. Parachute reaches to landing maximum velocity when the resistance is equal to the weight of parachute and his equivalent. Look at R1 is the air resistance V1 velocity of parachute. Therefore, R1 from given 90 kilogram weight, V1 15 kilometer per hour. R2 is the air resistance when the velocity of parachute is V2. What is the relation between R1 and with R2 and V1 with V2? R2 unknown, V2 10 kilometer per hour. What is the rule? Excellent student. R1 over R2 equals V1 squared equal V2 over V2 square. Resistance is proportional with square of the velocity. R1 over R2 equals V1 square over V2 square. Therefore, by substitution, 90 over R2 equals 15 square over 10 square. By using cross multiplication, R2 equals 40 kilogram weight. My dear student, by the end of application about the first Newton law, we know that the first Newton law, the body, it's not change from its case, state or motion unless the natural body act on it. Now we are taking problems about the second law. My dear student, look at the first example. A force of magnitude 10 newtons act on a body at rest of mass 8 kilogram to move it in its direction with uniform acceleration. Calculate the distance traveled after 12 seconds and its velocity. Solution. My dear student, look at, we have the force 10 Newton, velocity v naught equals 0, mass equals 8 kilogram, time 12 seconds. Therefore, equation of the body, ma equals F. What is the A? Substitution about m equals 8 and the force equals 10. Therefore, A equals 10 over 8, 5 over 4 meter per second. Since the first equation of motion V equal V naught plus AT, to find the value of the velocity, substitution about acceleration 5 over 4, therefore velocity equal 15 meter per second. Since, my dear student, second equation S equals V naught T plus half AT square, by substitution about T and A, S equals 90 meter. Another example. A train of mass 220 ton moves along horizontal straight railroad with uniform velocity of magnitude 29.4 meter per second. During the train motion, the last car of mass 24 ton is separated and moves with uniform retardation to stop completely after 1 minute of separation moment. Find first magnitude of the resistance per ton of the train mass, supposing it's constant. Number 2, magnitude of the force of the train's engine. Number 3, the distance between the remaining part of the train and the separated car at the moment the car completely. At rest given, remaining part of the train moves with uniform acceleration. My dear student, look at the solution. First, we have train. Look at the train, its weight 220 ton. There are two forces. The first force in right resultant of engine, but in left are resistance. First, study the motion of the separated car from laws of rectilinear motion. M equals 24 ton, V equals 0, V naught equals 29.4 meter per second. And T1 minute equals 60 seconds. Therefore, we use the first equation of motion, V equals V naught plus AT, by substitution to find the value of A equals negative 0.49 meter per second square. From the equation of motion of separated car, MA equals F. What is F? Negative R. F equals R, but opposite direction.